Today we're going to talk about one-sided limits. And continuity is also in this section, but we'll talk about that tomorrow. One-sided limits are exactly what they say they are. They're limits from one particular side. Recall how to find a limit, they have to be the same on both sides. Well, for one-sided limits, we're just ignoring one of the sides. So we'll start off with the notation. For one-sided limits, if you have the limit as x approaches c and you see this superscript negative, that means from the left. The reason why it means from the left is because this is the negative side of the x-axis, so you're approaching from the negative side. And if you're approaching from the right, you'll see this plus superscript, which of course means you're approaching from the positive side of the x-axis. So the usefulness of this, they help you determine if a limit exists, of course, if they're the same, but they can also help for functions that have quote unquote major domain issues, like some radical functions, for example. And what I mean is this. If you have this limit of this radical function, this radical function, because you can't take the square root of a negative number, meaning you're trying to take the square root of 3x minus 6. For that square root to even be existent, it would have to be greater than or equal to 0, because you can only take the square root of a positive or a 0 number. So if you solve that quickly, the domain of that function is x is greater than or equal to 2. So the regular limit as x approaches 2 doesn't make much sense because there's nothing to the left of 2. So if you try to take the limit of this as x approaches 2 from the right, that allows you to do so. To do that, all you have to do is, we're going to do it numerically. We'll just use a number that's close to 2 on the right. In other words, 2.001. And you notice I did that right here. I plugged in 2.0001 for x, and I got this. So that tells you that this graph exists on the right at a value of around 1. Now, if I were going to try that from the left, I would use maybe positive 1.999, and you can see what happens. When I actually plug that into here, I got a non-real answer, which I should, because you can't take the square root of a negative number. So that tells me a lot about the graph of this function. That tells me if I'm going to graph this function, I know the domain begins at 2, and as I take the limit from the right, you can see I'm about 1. So this graph would start at 1. So that does tell me a lot about the graph. That's not exactly how we're going to use it, but that's one useful, it's stupid, but useful use of a one-sided limit. Another thing you can see is something like this. If say we have the natural log function, and I wanted to find the limit as x approaches 0 from the right of the natural log function, I'm going to grab my calculator here and type in the natural, I'm going to try from the right, so I'm going to try the natural log of 0.0001. When I do that, ln of 0.0001. You get that number, -9. Getting even closer, I'm just going to add a bunch of zeros. Let the calculator do all the work. And I'm getting -25. And you'll see, as I get closer and closer and closer, this number is going to get higher and higher and higher and higher. So this is going to approach negative infinity. That's going to tell us a lot about the graph of the natural log. Now, if I go over here instead and try to approach from the left, we'll try natural log of -0.0001. Grab my calculator. Natural log of -0.00001, and it's going to tell me non-real answer. Which it should be, because if you recall, you can't take the natural log of a negative number. So what that tells me is this. One use of one-sided limits is the graph of the natural log the first one tells me, this tells me, as you approach 0 from the right, the graph will go to negative infinity. So as I approach 0 from the right, my graph is going to negative infinity, all the way down there. From the left, non-real answer means the graph doesn't exist. So that's one-sided limits for you. And to put the icing on the cake, remember when we talked about vertical asymptotes? We said vertical asymptotes occur where the top of a function, or where the bottom is 0 and the top is not. Well, that's not the definition. That's just how you find it for certain functions. The natural log function has a vertical asymptote at x equals 0 because we can see by the one-sided limit that that function goes to negative infinity. So you can use one-sided limits to find vertical asymptotes on these types of functions where you can't see it's going to be a number over 0. I hope that made sense. I'm going to stop that video here, and the next video is going to show you examples of more, examples of problems that we're going to see more often is the best way to put it. So make sure you watch that. See you for now.